I'm not done with that one. Alrighty, I'm gonna solve one like this. So, solving again, there's logs up there, there's multiple ones. Usually for solving, we probably gotta get rid of some stuff, right? Before you can get rid of logs, what do you gotta do with them? Combine. So my log base 3's here. There's two of them, right?
Yep.
And they're adding.
Yep.
So what's gonna have to happen now if you combine them? Multiply, so it'd be FOIL, yep. So you see I'm multiplying these two parts, because the add will turn to multiply when it turns into one log. And the middle term will drop out because these are conjugates, right? Difference of two squares. So it's actually log base 3 of x times x. The outside gives me 1x. The inside gives me negative 1x, which those cancel, right? Oops. They cancel. And then I'm left with negative 1 times 1 gives me negative 1. So it's pretty much x squared minus 1 equals 2. And then, what can I do now to get rid of stuff? What? Yep, let's get rid of the 3 of the log push and pump, right? So the log goes away when you swing that over. And now I have what on this side? X squared minus 1. And this is 3 to the squared, which is 9, right? And then how do I finish solving that? Add the 1 over. So I get x squared equals 10. And then how do you find that? Square root. And if you couldn't, so on the test, I don't know if it'll be nice like this. If it's not a nice, where it's x squared in a number, from this step, what would you have to do on the test? You might have to factor or
Oh, I don't like this.
quadratic. I can't remember what the test had on it. Okay, what do you get when you get an answer here on this one? You get two answers. It'd be plus square root 10 or minus square root 10. Okay, and what do you know about logarithms? What number will not work up here?
Negative.
A negative, so then you know logarithms can't be negative, so then in this problem, that'd be the only answer that would have worked. Okay, but on the test, you might have to do factoring, you might have to do quadratic formula. What's the quadratic formula?
X equals negative b plus or minus the square root of b squared minus 4ac all over 2a.
Yep, so then that's the quadratic formula if you need to use that. Okay? Any other questions or anyone not done running on this one? Alright, another question on the test. Got two more, I think. Between what two consecutive integers, so what's the word consecutive mean?
Oh, first.
Uh,
No.
consecutive, in order.
In a row.
Sequence right next to each other, right? So two numbers right next to each other that are integers, those are whole numbers. What's that answer be landing at? Well, let's actually jump down to here. We can't plug that in exactly. Let's use the change of base formula to express that and then solve it that way. Who remembers what the change of base formula was? It was log of the big font number, so which one's a bigger font number here? 88's the bigger sized font, divided by log of the smaller font, or the subscript, which would be what?
3.
3. So in your calculator, here's how you can solve that.
.075.
Is that right?
No.
4.075, and it says approximate to the nearest thousandth. So tenth, hundredths, thousandths, what's the next number after that?
4, so it wouldn't go up.
4, it wouldn't go up, yep, so then that's my answer right here.
Unless you wanted to, well, you could.
Is it only a 4 here after this?
It's a 4, another
Yeah.
4, then a 7.
Okay, then we'll leave it here, because tenth, hundredths, thousandths, so we're stopping on that number. Okay, so between what two consecutive integers does this answer lie?
4 and 5.
4 and 5, 4 is the smallest, and then 5 is the biggest, and it's in between 4 and 5. Now, another thing you can do here, let's say you didn't remember the change of base formula. I can do it this way too. If you forgot the change of base, could I go log base 3 of 88? How else can you solve a problem like that? You set it equal to what?
X.
X, and you do it with this 3.
Hold and push.
Push and pump. And now I get 88 equals 3 to the x. How do you solve a problem when there's an x in the exponent? A what?
You got it, same base?
Okay, yep. So if we can't get same base here, so what's the other way? Log, or, for you lazy people out there,
ln.
ln, what you do to one side, you do to the other, and now what can I do with this x? Bring it out in front, and I get ln of 88 equals x times ln of 3. And then how do I solve that? Divide by ln of 3, divide by ln of 3. And isn't ln of 88 over ln of 3 the same as log of 88 over log of 3? Yep. So then you see how that got me back there. So this is a longer way of doing it, but if you know how to solve it when the x is the exponent, that'd be a way of getting to your answer. Alright, last problem here, I think, right?
Yep.
Oh, here we go, ready to solve this. So solve 4 to the x equals 42. And round to the nearest hundredth. So again, the x is in the exponent, and 42 and 4 are not able to be the same base. So when you can't get the same base, there's only one way to do it. And what is that? Introducing log, so either ln or log. I'll switch it up this time and not be lazy. I'll go log. And what you do to one side, you do to the other. And the reason why we did log is because we can do what with that x now?
Move it.
Move it up in front.
You divide it.
And since it's x times that, to get rid of that times, I would divide, and we do to one side, we do to the other.
It's
2.696. So if we're rounding the nearest hundredth, tenth, hundredth, what would that actually round to then?
77.
So it'd be 2.70 then, right? If we're going to the nearest hundredth. Yep. And that's the review sheet, correct?
Yeah.
Okay,
Should I stop it?
yep, that'll be all.